Phone's working. Can everyone hear me well? Cool, awesome. So thanks so much for being here. By the way, if you want to see the slides that we are talking about today, we are talking about microservice. The slides are available in this URL, http bit.ly.com/Red Hat MSA. Okay. By the way, I have been already introduced, but I like to say that I've been working for Red Hat for more than 7 years. I started as a software as a consultant there in Brazil. By the way, I'm Brazilian, and it's my first time here in India, so I'm enjoying a lot. I see that in culture we have many things in common between the Indians and the Brazilians. Then I moved to a software engineer role, and I'm living in United States for like 2 years. But I'm not a native English speaker, so if you have any questions to do, please speak a little bit slowly so I can understand you better, okay? You can reach me by comment for doing questions during the session and, of course, at the end of the session. As a background, I'm essentially a Java developer. But given that we are also having a lot of energy being placed on DevOps practices, I'm also involved a lot with containers, okay? Something that I like to do in my spare time is build and fly my own drone. And some people will ask me, why do you prefer to build your own drone instead of buying, for example, a DJI Phantom where you can have everything in a box. You have a controller, a battery charger. You can just turn on and fly just like an Apple computer. Well, I'm the kind of guy like old school that prefer to build my own gaming PC, right? So because I like to have the freedom of choice. With drone, it's more or less the same. I can choose the size of propeller. I can choose the motor. I can choose the receiver. I can choose the flight controller. So more or less, it's like microservice because with microservice, I have the freedom to choose the technology. But the only difference is because with drones, I cannot replace the motors while I'm flying. But with microservice, I can say that I can change, I can introduce a new version while it's running in production. And that's something really cool about microservice. By the way, since we're talking about microservices for Java developers, I'd like to invite everyone here to at least take a look on microprofile.io. It's a micro specification for microservice for Java, using Java technologies, okay? It's a joint effort by Red Hat, IBM, Payara, Tom Tribe, and a lot of other jugs involved, okay? Something that I really like about a microprofile is the logo, because if you take a look on the logo of microprofile, it's like a big duke formed by small dukes, like small micro dukes forming a whole solution, okay? And by the way, since I already invited you to visit microprofile.io, I also would like to invite everyone here to visit developers.redhat.com. Visit and register yourself. By the way, if you get the confirmation page saying thank you for registering on redhatdevelopers.com, you can go to Red Hat booth and get a t-shirt for you, okay? But it's not only because of the t-shirt. The Red Hat Developers Program has the idea to provide content for us, for developers. So there you can find valuable resources like free access to products, free access to free ebooks, blog posts, articles, and many things that I really believe that can help us as developers, okay? So let's talk about microservice. I'm talking a lot, and I didn't talk until this moment about microservice. The first thing that we need to have in our minds when we are talking about microservice is that it's all about agility. It's nothing else. It will not make your code easy to produce, easy to deploy. In fact, it will be the opposite. It will be hard, really hard to deploy because you will have thousands of moving pieces using different versions, different technologies, okay, that needs to communicate between each other. That's why it's hard to deploy. So even being hard to develop, hard to deploy, let's understand why people are so excited about microservice nowadays. And of course, to understand that, we need to have one thing in mind. The reality of a green field and reality of a brown field. The green field is where you have nothing. Two guys decided to start a new company, a new startup. They want to release their code faster. So they decide to adopt microservice architecture. And of course, there is the reality of a brownfield, where a new application, where you have an existing application inside a company, a big monolith that has been under development for the last 5 years, and they decide to adopt a microservice architecture because their competitor are releasing code very often, every week. Sometimes every day a new version is coming with new features. So both of them have different realities. But in common, both of them need to go through a kind of evolution process. And both of them will need to first have elastic infrastructure. An infrastructure that can shrink and grow based on their needs. This is the first step of this evolution towards microservice architecture. The second step would be reorganize your team and start adopting DevOps practices. With DevOps practices, you can start having automation with tools like Ansible, Puppet, and Chef. Because if we want to release thousands, let's say hundreds of different moving pieces, it's good to have automation, right? We don't want to do SSH on each server and do an update by hand. The fourth step of this evolution toward microservice is to have CI/CD deployment pipeline and adopt containers. That, of course, when you have DevOps practices, that becomes really easy to have. With all those pieces in mind, in its place, then finally you can have your first microservice, right? And who knows, now that you have your first microservice, you can maybe become the next Silicon Valley unicorn. Because, of course, now you have everything to keep producing more and more microservices, to keep being more agile and releasing your code faster than you used to do in the past. By the way, all those requirements that I mentioned by the way, Martin Fowler talked about these requirements in his blog post that's mentioned here in the link. I know that it's a little bit small for those who are seated in the back, but again, you can go to the slides of this URL and see the requirements of microservice and why it's important to have each one of these requirements in its place. So have DevOps practices, have automation, have CI/CD. But we'll talk about that. and I will also show a demo that takes different parts, different technologies, and make it work in a microservice architecture. Well, first let's understand our reality. As a developer, as a Java developer, we all need to place our code in production, right? And to run our code in production, we have to agree about the operational system that we decide to use, right? What version we will use, what security patch we will apply, what package we will include in our operational system. Then we need to agree about the Java virtual machine. Some companies are still using Java 6, others have adopted Java 7, and some companies decided to go to Java 8. Okay? Then we need to agree about the application server. Inside our application server, we'll have our enterprise archive, and then we'll start to place our war archives inside. Of course, to avoid duplication of code, we take parts of the parts in common and place inside a jar file, right? And then our application starts to grow and it becomes very popular. We need to release more war files, and we need to decide between the libraries that we will use. If we will decide to use Hibernate 5.10 or 5.11, which version of Spring that we will use. Okay, let me be closer. So once that we agree on all those versions, we finally release that to production. To maintain this wild beast, this big monolith, we have a team of programmers, DBAs, product managers, ops guys, quality assurance, okay? But what happens in reality is that each logical part of application is managed by a different team. So for example, we have a team that takes care about the sales part, right? We have another team that takes care about the finance. Another team takes care about the billing system. Another team takes care about the data warehouse management, right? That's what happens in reality, okay? And to release this big wild beast, this big monolith in production, sometimes we take 24 weeks to release it. Of course, when you start to adopt those technologies, those practices that I mentioned, like for example, you start to adopt containers, you can have, or you start to adopt agile practices, you can reduce that to 12 weeks. And then you start to use Linux container, you can reduce that to 8 or 9 weeks. Later, you decide to adopt continuous integration pipelines, continuous deployment pipelines. You can release that in 6 weeks. But usually, what I've seen when people adopt agile practices is that at the end of a sprint cycle that usually takes like 3 weeks, they release a software. In really high trust environments, they can release their software more than once in a sprint cycle. Like, for example, at the end of a week, you release a software. But the question is, how can you deploy faster than a 3 weeks sprint cycle? How can you deploy, for example, 10 times a day? Because there is a book called The Phoenix Project that mentions that you can do several deploys a day. And let's think about our competitor. Our competitor sometimes are releasing their software once a day, twice a day, with new features, and you need to be as faster as he is at the when he decides to release a new feature, okay? And the only way that you can do to release your code faster is if you decide to break up your monolith in small pieces. Because if you are not attached to, you are not, if you're a piece that you produce, for example, a sale, I mentioned earlier, the sales part of your application, if it's not really attached to the finance system, you can release it as long as in the moment that you want. If your warehouse management system is not attached to the finance system, you can release it any moment, right? So that's the point behind microservice, is that you can deploy each part of your software independently. So suppose that in the first week of a cycle of a development of a big application, you decide to release the part A, C, and D. On the second week, you figure out that your part A needs a patch. It needs to evolve. So you release A1 and the part H and G. And the third week, you release B, F, and I, and so on. So that's the point behind microservice. With microservice, you can achieve agility and you can achieve independence. And with independence, it will help your company to be more agile, more flexible, have more speed to release the features that you want, the patch that you want, the security fixes that you want to the production. Because let's be honest, no matter if you have the latest and the coolest technology on your laptop, if it's not there running in production, it doesn't have any value to the customer or to the company that you work for, okay? You need to have the code running in production. Another thing related to microservice is because each one of those teams that I mentioned, they can decide what is the best technology for them. So suppose that for the sales application, they decide to use the sales part of your application. For the sales service of your application, they decide that's good to use a Postgres database using Spring Boot, for example. And the other team decided that's good to use Java EE with MySQL. Another team can decide to use Node.js with MariaDB or MongoDB. Another team can decide to use PHP. So that's the idea of microservice, is to be independently not only related to the technology, but also from the business standpoint, business point, okay? But by the way, in every microservice talk, you will hear about the Conway's law. And the idea about Conway's law is that if the communication infrastructure of your company is a mess, very likely the microservice that you produce will be a mess as well. Because the law says that the design of your application will be a copy of the communication structure of your company. So before thinking about adopting microservice architecture, it's good to have a very clear and a very well-defined communication structure on your company. Okay, so be aware of that. Many people, when they see this kind of scenario where you have different parts, different systems, different servers, they tend to think, okay, I know how to solve the integration of this service. It's easy. It's just place an enterprise service bus in the middle, and I will be fine. I know how to integrate that. I have studied SOA, service-oriented architecture. I know how to do that. But first thing, SOA, service-oriented architecture, is not microservice, and microservices are not SOA architecture, okay? Because in SOA, we had dump endpoints, and smart pipelines. So the pipeline was responsible, the ESB, the pipeline, the enterprise service bus, was responsible to get the message, to transform the message, to route the message, and reach the message, and deliver it to the dump pipeline, to the dump endpoint. And in the microservice architecture, it's the opposite. You have smart endpoints and dump pipelines. The pipeline doesn't do any transformation, any enrichment. It's just the endpoint needs to be smart enough to know what service needs to be called and what to do if the service is not available, okay? And we will talk about smart endpoints when we talk about patterns of invocations, okay? But okay, service-oriented architecture still have its place. For example, if you need to integrate different monoliths or in a business-to-business scenario where you have one company that needs to talk to another company, SOA architecture is still valid nowadays, okay? Be aware of that. While microservice is to have different parts of services, of microservices, working together to a single application, okay? Talking about smart endpoints, we need to be aware that with great power becomes great responsibility, okay? And you understand that, again, when we talk about smart endpoints. Okay, so we know that the first idea of microservice is to be independently deployable, right? So to be independently deployable is one thing, but we need to have one service talking to other. And the only way to do that in a way that you don't, that you can evolve your application and doesn't break the things is to have your project very API focused. So you can change the implementation, but you cannot break the contract. You need to have a very clear API. But of course, sometimes you need to evolve the API as well. Sometimes you change something. So for that aspect, for that part, for that principle, we need also to have evolutionary design. So suppose that you have an application, a microservice that talks to another in a format called version 1, V1. And for any reasons, you need to update the API to V2. But remember, it needs to be backward compatible until every other service can talk to V2. So don't break backward compatibility, okay? It still support the V1. So that's part of evolutionary design. Of course, another part of being independently deployable is to have decentralized data management. That's another part when we are talking about microservice. So for example, each microservice needs to have your own database. So you can ask me, are you saying that if I have 200 microservices, do I need to have 200 databases? At least 200 schemas, okay? Because that's the point. Suppose that you want to refactor your database. Suppose that you want to have a new field, or you rename a column, or change, or drop a table. If you do that in the customer table, let's talk about the customer table because it's very famous. Every part of our application usually talks to that table. If that impacts another microservice, you are doing something wrong, okay? It needs to be decentralized. Each microservice needs to have your own data. Talking about data, does it mean that I will not have relational integrity between fields and tables. Well, sometimes in those cases, if we need to have different database, it means. And for those who start to think about that and bring that idea to your company, it will very likely cause a problem with the DBA of your company, right? The DBA, when hear about that, they will try to kill you. So I suggest you to get this book, buy it to him like in his birthday or for any holiday, give to him and say, hey, you're my friend, let's talk about microservice later, okay? So let's talk about patterns of invocation of microservice. The first one is when you have the browser locating and invoking each one of the microservices. So let's think, for example, on a screen like this. You can think like in Amazon. You can think about Walmart, where each part of the screen comes from a different microservice. So for example, you have the price coming from the price engine. You have the reviews coming from the reviews engine. Or you have, for example, the details of the product coming from the details microservice. So the point is, what happens if one of these microservices fails? Well, one of the idea of a microservice architecture is to be prepared for a failure. So in this case, suppose that the location-based availability is not working. It's offline. We will not shut down and start losing sales just because one microservice failed, okay? So you need to provide a fallback. In this case, for example, this application is running on a mobile device. So why not the fallback is to use the GPS of the mobile device and say, where is the closest store? You don't know if the closest store have the product, but if the customer is really interested, he can use the GPS, go there, and check if the product is available. Or maybe make an order to have the product delivered on that store or delivered to his home. So that's the point. You will not lose sales because one microservice failed, okay? Another pattern to invoke microservice is to have an API gateway. So the purpose of API gateway is to have a single point where the browser talks to the API gateway, and the API gateway will be responsible to locate and talk to the other microservice, and also handle any failure. And sometimes people ask me, is the API gateway a product that you buy from a company? Is that a specific technology? You can think about an API gateway just like another microservice. Okay, it's just a microservice that will talk to other microservice. Because it's very common, you have a chain of invocation. For example, a microservice is not enough by itself to know all details of the business. Otherwise, it would not be small. It would not be micro, right? So a microservice, very often, they will need to talk to another microservice that will need to talk to another microservice that will need to send data to another one, and so on. This is a chained invocation. Okay, question?
Can you hear me?
Yep.
Okay. How does high availability work with Microservices?
Yeah, but now I cannot hear you. I think he will get you a microphone.
I was talking about the
High availability. This is something that you should concern, but related to the infrastructure. Okay, so the question was, what about high availability? That's right?
Yes.
So the point is, This is a concern of the infrastructure, but it's not really a business concern, okay? The business concern is, okay, does it solve my business problem? And availability is it's something that you should worry, each microservice should worry. And I will talk about that in the next few slides about the concerns of each microservice, okay? But now talking about the chain of invocation, what happens if something in the middle fails, okay? What happens? So this is why I said that the endpoint should be smart enough to take the decision. From the business perspective, should this previous microservice be satisfied with the no response from the next microservice? Or should it skip that failing microservice and invoke the next one? Or should it wait? What it should do? This is a decision that the endpoint that the microservice should decide, okay? And of course, we can have mixed invocations. We can have the browser talking to the API gateway that will invoke the service that needs to invoke another microservice, okay? Now talking about the microservice concerns. Since for example, as Java developers, we are all used to get our business code, place it inside an application server, and the application server will provide us the thread pool, it will provide us authentication, monitoring, logging, all those kind of stuff, right? Even high availability. We can create a cluster of application servers with session sharing, cache sharing. But in a microservice environment, we need to think that each microservice can be used with a different technology. I can have a microservice in PHP, I can have a microservice with Java, we can have a microservice using Node.js, another microservice using Go, .NET. So all those concerns provided by a Java application server, like, for example, logging, monitoring, authentication, how we will build and deploy our microservice, how we will do resilience, load balancing, scalability, need to be performed by someone else than our application server, right? And to solve all these microservice concerns, Red Hat has a suggestion of an open source project or a product that can solve. For example, how you will build and deploy your microservice. It's suggested that you place that inside a Docker container and release that in an orchestration tool, orchestration project like Kubernetes. How you will invoke your microservice? You need to decide if you use REST APIs, if you use messaging. For tracing what microservice called which microservice, we can use Zipkin. We'll talk about Zipkin later. For resilience, there is a project from Netflix called Hystrix, okay? And for people who are wondering what's the space, what the space of containers in this world for us, for developers, we can see that most of these concerns are solved by containers. Like, for example, we can see here the load balancing, scaling, elasticity, build and deployment pipelines. About authentication, we can use a project like Keycloak that provides open authentication for us. Okay. Let's go back to a typical usage pattern where a service A needs to call a service B. What happens if service B is slow to respond? What our users usually do when the service is low. They click refresh thousands of times, right? And this, this will cause is to make our service be even slower. So we need to have a kind of circuit breaker that that perceives that the service B is slow to respond or is offline, and avoid sending more requests to the service B. And even more, if the service B is performing with an error, a timeout, or a 500 error, or a 404 error, we need to have service A still having a response. We need to avoid a cascading failure. So that's the point of using a circuit breaker or a bulkhead. And to solve that problem, I talked in the microservice concern about histories. You can use histories, which is API provided by Netflix, that you can just say, okay, I want to connect to that service. And in the histories API, you will provide a Java interface, and you will implement this interface to say what I should do if the service B is not performing the way it should be. What I should do if the service B is slow to respond or is giving me an error. Okay, I can provide here an implementation of that interface. The code is really simple. Okay, in this case, I just used a lambda, a Java lambda to return a fallback message. But it could be any other business resolution. Suppose that the business decide that I want to, for example, suppose that I want to invoke a credit card microservice that's not available. If the business decide that I will place a reservation and I have 24 hours to receive the payment, okay, you should implement that. But the point is, you are always treating your code knowing that a remote invocation will fail at any moment, okay? And a nice thing about histories is that each histories client know the status of the service, right? Because each histories client know how many requests were made. It knows the average response time. So those metrics can be used by another part of the Netflix OSS API called Turbine. Turbine collects all those metrics, and those metrics can be used in a histories dashboard. So the histories dashboard will give you something like this. You will see all microservices here, and with a nice graph, and each graph will allow you to see the volume of invocation along the time. It will know the status of the circuit, is still closed or it's open. I'm avoiding to communicate with the failing microservice. What's the average response time? Okay. Now, in the same scenario where a microservice A calls B, that calls C, that calls D, sometimes we need to know where is the bottleneck of our request. Or we need to know if a microservice is being called or is my microservice being skipped. So it's good to have also a distributed tracing. And a distributed tracing with Zipkin can be performed using HTTP headers. So the header will be placed inside the request, and the client, the server that will receive that request knows which time it received and can give me this kind of graph with the average response for each microservice. Okay? I'll talk about monolith to microservice later because I want to show you that in a demo. Because talking about microservice is easy, but how about having different microservices running on this laptop? And to show how that works, I will use different technologies here. I have a microservice called Bonjour that is a hello world implemented in Node.js that replies me hello in French. I have Spring Boot that returns me hello in Portuguese. I have Hola that replies me, that was implemented using JAX-RS. I have Vertex for those who were in Burst session or Thomas session today. All those microservices have been deployed inside OpenShift that runs on top of Kubernetes. Who have ever heard about Kubernetes? Nice, nice, nice. So okay, so I have here Aloha, I have an API gateway, and I have a front end here that I will open so you can see, for example, the browser as a client. So every time that I do an invocation here, it's the browser that is using JavaScript to locate and invoke those microservices. So what about the API gateway? Okay, I have the API gateway here as well. I can invoke, the API gateway will talk to those microservices and bring me this response. I have also a service chaining, okay? So I can invoke. And I have also here a Zipkin dashboard that allows me to, based on those requests, to analyze, for example, the dependencies. So I can easily see here that I have the API gateway invoking those services, and I have also a chained invocation here from this service to this service. I can even see that the service called Hola is used by the API gateway, is used by Hola service, and it uses Aloha. Okay? I can also perform fine tracing, so I can see here, for example, I have a chained invocation here. I have the API gateway invocation here. I can open each request and see details of the request. Okay, so this is an example of a distributed tracing. But let's start to make things more interesting. What happens if something in the middle of this chain is not responding? So let's stop the Aloha service. Okay, let's shut down it to 0 replicas. Now, when I try to invoke, you can see that it takes a time to respond, but it's responding me with a fallback message. That's even true with the API gateway. The API gateway tries to communicate, and you can see it's taken a while, but the complete application is still working. I have a fallback programmed inside Hystrix to give me that response. But take a look here on the Hystrix dashboard. Let me open the Hystrix dashboard so we can see what's happening with those microservices. So I can monitor them. And let's perform some invocation. You can see here that's give me 100% red. So it knows that the service is not available. Okay? But what our users usually do, they click several times on the application. Now you can see that that Hystrix decided to open the circuit. You can see it here in red. The circuit's opened. And now it will not try to communicate anymore to that service. You can see that I'm failing fast. Remember that previously it took like 1 second to reply. Now it's replying really faster. That's because it knows that the service is failing. Okay, but let's now do load balancing. I know that this service is problematic, so let's increase that to 3 replicas. Now I will have 3 replicas responding to that service. Once that the service become available, you will see that it will change the color. So now I have 3 running. Let's do an invocation here. Okay, it starts to reply, and now everything in my histories dashboard is green because everything is working now. Okay, and you can see in this case the load balancing. I'm not using a stick session, so every time that I click, I see a different name, a different role name here in replying for this service. Okay. What about authentication? By the way, let me. Related to authentication, I have endpoints here that are not I'm not authorized to use, okay, until I open the login page. So once that I click on login page, I will be redirected to a server that will provide me a token. And this server is Keycloak. A nice thing about Keycloak is that I can choose how my login screen will be. So for example, let me open here the administration page of Keycloak. And I have a way to control how my login screen is. So suppose you can even go to this URL, okay? If you go to front-end, using your smartphone, frontend-hello-world-msa.app.rafabene.com. If you click on the login screen, you will see now what you can see on this screen. But if I can enable, for example, users to register themselves, okay? Now I can see a new user. Or I can enable forgot me. Okay, now I can see a forgot password link, or remember me. Okay, I can even enable an authentication with different identity providers. I can, for example, use GitHub, Twitter, Facebook. So I have previously configured GitHub here. So once that I enable, I can see a button that allows me to log in with GitHub. So you log in here with GitHub. It will get a token that contains my credential, and you can see here that by the way, let me see. Let me log in, log out, and log in again with another user. This will get me some credentials and allow me to get the proper role and decide if I'm not allowed to use that microservice or not. Okay. Something that a microservice architecture should be also prepared is, for example, to a blue-green deployment. So a blue-green deployment is where you have, let me show you a picture here from Bluegreen Deployment. Is when you have a green environment and you decide to prepare a parallel environment called blue, and you just use the router to switch the key between the green environment and the blue environment. So let's do that for using the API gateway. So here I have the API gateway. And I can go, by the way, just let me just okay. Let me go to OpenShift, and I have a place here where I can control the routes. So I have a route for my API gateway. I can change the route to point to another version of the service that I deployed earlier. So I have here API Gateway Blue. I just do that. If I come here to the API Gateway and click refresh, I can see now a new version saying GIDS says plus the response of the microservices. Okay, suppose that I made that change, but that change is not what I wanted. I can change my route again and return the route to the previous service. And now, if I refresh, I can see again the previous version of my API gateway that does not add anything to the response of the server. Okay. By the way, let me do something. So let me simulate an error here. Okay. I have a project. I will introduce an error on the system, and we will fix it using a continuous integration, continuous delivery pipeline, okay? What I'm doing now is introducing C project, hello world MSA. I have a project here called Aloha, okay? And I'm building a new version that contains a typo on the message. And you will see a different kind of deployment. What I did was a blue-green deployment. And once that I introduce a new version, it will create, OpenShift will automatically trigger a rolling deployment, which is introduce a new version among those three each time. So for example, you can see here that each new version, I have a version called Aloha, and now it will have a new one called Aloka. Okay, it was a typo that I introduced. So the idea here is that I will fix it using a CI/CD pipeline, because we want to release our code faster, right? So once that we commit our fix in GitHub, we want that Jenkins, for example, get that change, compile, test it in a staging area, and then we can approve or not to go to production. So I have here in this same cluster Jenkins running. Let me just log in. And this service here is configured to use a Jenkins pipeline. And this I will trigger the build, and I will show you what's a Jenkins pipeline, how a Jenkins pipeline looks like. Suppose that I committed I commit the fix, and once that I commit, Jenkins will automatically load that, and together it will load a definition file of Jenkins that's on the same repo. And the Jenkins file contains all the stages to build and release this microservice. So the first thing that it will do, it's a git checkout. It will build my project using Maven, deploy that in development, run the tests, deploy that to QA, and wait for a human approval to deploy that in production. So I can see it here that it already deployed me in the development area. So I have my project -dev, which means that's a development. I can see here, let me open the configuration page, that this version deployed now has an image call with a hash D03BF. If I go to the quality assurance area, we will see that this Docker image has been promoted to the quality assurance because the tests have completed. So here in the quality assurance -QA, I have the same image and the same container running. So for example, I can open here in the quality assurance area, -QA. I have here in microservice a Swagger app. Swagger allows me to specify REST endpoints using a JSON file. And it also allows me to use this interface to try my microservices. So for example, I can use my own microservice to test itself by clicking on this button in the endpoint Aloha. It will try. Okay, the response is Aloha. It's not Aloka. So okay, it means that this microservice is good to go to the production. In production, what I have is the microservice with the error. It says Aloka instead of Aloha. Okay? Let's go back to production and let's go back to Jenkins. Jenkins is now waiting here for human approval. Okay, so I can reply proceed. When I click proceed, it will perform a Canary deployment. So what is a Canary deployment? Instead of replacing everything, every version 1 to the version 2, it will add the version 2 in the middle of it will place it under the same route. So now I have, despite this minor error here, I will have 3 versions of Aloka and one version of one instance replying the Aloha version, which is the right one, okay? So now I know that the version is working. I can control my Canary deployment, increasing, for example, here I have 3 of previous version, 1 of the new version. I can now do 50-50%. I can reduce this to 2 instances and increase this to 2 instances. And you see that I will have now 2 versions responding Aloha and 2 versions responding Aloka. Okay? So 2 Alokas, 2 Alohas. Okay, now I can do, I can shut down the previous version and keep just the new version running. So I will have just the right version being presented in this microservice. Now I have just the right service responding, the Aloha service. Okay, since we have 3 minutes, let's talk about the monolith to microservice. Given that people see that a microservice is not that hard, they start to wonder, how can I go from a monolith to a microservice architecture? The most accepted pattern is called strangler fig because the fig tree that grows and embraces everything that's in the middle of the fig. So that's the idea of the strangler fig pattern. you have your big monolith, and you can get a piece of your software. Probably there will be some microservices that are coupled. You can have like 3 microservices that are coupled, plus its database, and you extract it. And you can keep refactoring your application and extracting parts of your microservice until you finally have a client accessing that microservice instead. Once that everything is inside a microservice, you can start to strangle your monolith to finally have no monoliths and only microservices running. And one message that I would like to give to you is that microservices are not for everybody. Sometimes you just need a big monolith, a big and fast monolith that will be fine, okay? Or even more. Sometimes you can decide to go from nothing to a microservice architecture. If you go to that path, you will find dragons and lizards. That's not something that you want, okay? So why not first have your monolith and then have your just one microservice so you can try and see the things that you need, what you need to have in your architecture to support microservice, to finally have your architecture using microservice in general, okay? So any questions so far? Sorry? Sorry, I can't hear you. Related to performance. Well, given that you are running everything that's running in distributed system, it's not running on the same machine, you will have latency involved, okay? So it's not a good practice for example, if you want to do a report or something that requires very powerful or involve different microservices, you should not be concerned. The performance should not be the first thing that you need to think when you decide to adopt microservice, okay? Because you have latency, your service might not be available, okay? So we are dealing with distributed system. So it's not, if performance, the answer is, if the performance is your top non-functional requirement, probably microservice is not the best solution for you. Okay? Any more questions? So thank you so much. Don't forget, you can reach me by Twitter. And thank you.